All right, let's start. Let me share my screen. Can everyone see my screen?
Yep.
1 second. Welcome to the Harvard community meeting. Good evening, good morning, wherever you are. The agenda for today is basically 2 issues. We're going to look at discuss being able to leverage the 2.0's OSAT compliance or OSAT capability to store certain artifacts that are used in machine learning workloads on Kubernetes. This is to be presented by Cloud, which is a public cloud provider in China. And then we'll look at some of the progress we're making on the proxy cache. And if we have any time left, we can talk about the latest 2.0 release, take some questions, whatever. So I will kick off an introduction on the first item, and then Henry and someone from Cloud can give some background and share the proposal, which has already been submitted as a PR in the community repo. So if you've never heard of them, Cloud is a pretty well-known public cloud provider in China. Does quite a bit of machine learning on Kubernetes. They contribute to TensorFlow, Kubeflow, upstream, other projects, and essentially these workloads or these models generate their own data types, artifacts that need to be stored, curated, and shared, right? So some type of a content management system. And being that there is no dedicated registry for these machine learning artifacts on the market right now, the latest version of Harbor being that it can host any OSI artifact. So we had some, exchanged some ideas and thought about, why not distribute these as OCI artifacts and store these in Harbor? Because we have the role-based access control, we have the policies around lifecycle management, policies for deploying, replicating, right? And Harbor is already running on a Kubernetes cluster. We want to make it the best registry for Kubernetes workloads. So that's what we're here to explore. So if you've heard of us talking about Harbor being to store things beyond images and Helm charts like Singularity, Open Policy Agents, CNAPs, etc. But here's a case where you're onboarding something that's totally new, totally foreign. So I think regardless of whether Harbor is the right solution for this type of workload, it'll be interesting, it'll be illuminating to see what that process looks like, the process of looking at what the registry vendor has to do and then what the artifact vendor has to do, and see if we can potentially turn these data types into something that can be hosted and managed on Harbor. So with that, I'll hand it off to Henry. So stop sharing my screen, and then Henry can talk about it.
Hi, thanks, Alex. Actually, I would like to have the person Gao Ce from the Cloud to share his PowerPoint and also discuss the proposal that he has written. So basically, Cloud, yeah, as Alex said, is our longtime partner in the Harbor community since the very beginning of the project. So they have been using Harbor in their product for a few years. Now they're trying to integrate machine learning model management into Harbor. So maybe I'll let Gao Ce to talk about that. Ce, are you there?
Yeah, I'm here.
Yeah, sure. So you can maybe have 15 minutes or 10 minutes, Alex, for this topic.
Yeah,
okay,
I think 20 minutes, whatever.
Okay. Yeah.
So let's begin. I'm sharing my screen.
Yep,
can you see my screen? Yeah, okay. So Hello, friends from Asia and Europe. Thanks for your time. Today, we will present a proposal to Harbor community. We want to have an extensible architecture for the artifact processor in Harbor core, and we want to make Harbor more extensible for user-defined artifact. And this is the linked issue here, and you can also get our proposal in this issue. And this proposal is written by Huang Yiyang, and he's online today. He is also the corresponding author for this proposal. And Zhu Jian is our technical lead in TechCloud, who he is working on our internal Docker registry, but he's not online today in this meeting. And my name is Gao Ce, and I am working on running machine learning workloads on Kubernetes. And I'm maintaining some projects in Kubeflow community. If you are familiar with Kubeflow, the PF operator and PyTorch operator and something else are maintained by me. So let's begin. This is today's agenda. First of all, we will introduce the background of this of our proposal, and after that we will illustrate the motivation of this proposal, and then we will illustrate our design. We have two designs for the feature. The one is in-tree implementation, and the other one is out of tree, and we will show the community these two approaches, and we can discuss it after this illustration. And okay, so let's begin. First, we need to introduce some basic knowledge about deep learning, because our motivation is related to deep learning. So, sorry. First of all, let's have a look at our company. TechCloud is a company focusing on Kubernetes and deep learning to build personalized cloud services. And here is our GitHub organization. You can check out here. And we are one of the top contributors in Harbor community, and many other projects, for example, the Kubeflow or something else. And okay, it's about the company I'm working at. And after that, we will introduce the machine learning basics. For a basic machine learning workflow, we have three processes here. First, we need to train the model. If you know about deep learning, you must heard about model training or something else. So first, we need to train the model locally, and after that, we need to distribute the model. And after that, finally, we will serve the model in production. So when we train the model, we have to write some machine learning code here. Here is the pseudocode. You can see that after the model training, we will save the model here. We will save the model to the local file system. And after that, we will get the model in the local file system. You can see that we get the model here, and it is a TensorFlow saved model. And after that, we need to distribute it and serve it in production. So we have to use, for example, SCP to copy the model from the development environment to the production. And after that, we can SSH to the production server and use TensorFlow model server to serve it. So we think that SCP is not extensible. We want to distribute the model with OCI-based registry, for example, Harbor. So we have such a client, we call it ORMB. And we can use this client, this binary, to save the model and push the model to the Harbor registry. After that, we can just pull it in production server and export it. After that, we can just use it to serve it online. And here is our design of this binary, or we can call it a client. we define our own model config similar to the OCI image config here. We need to define it, and here is the model specification. You can see that it is similar to the model config. Similar to the image config in OCI specification. We have created time, and we have author, and we have description, and something else about the machine learning. We do not need to know about it. We just know the structure of this config.json. So we can think it is the metadata of the model. Yeah. So this is our own open source project, and we are using it to push and pull model from or to Harbor registry, and we found something not easy to implement in Harbor. For example, when users call this API, this Harbor API to get the model artifact details, we can get this response, and you can see the media type is our own defined media type, vnd.tycloud.model.config, and it is the media type of the config layer, and we can get the type model, and this type is defined is processed by Harbor default processor, and when users get Helm chart instead, he can get more information here. For example, besides the media type and the text and something else, he can also get the extra attributes, and it is processed by Helm chart processor in Harbor core, and the information here is stored in this config layer. So we just copy the config layer to the extra attributes, and we add this extra attributes in this API response. And we also want the config JSON for model. So we want to save the model config in the API response too, not just for Helm chart or say AB or some standard artifact types. But we do not want to keep the artifact-specific logic in Harbor core, since it is not necessary. Because, as you know, our own model specification is not mature, and we are still iterate it. So we do not to break the scalability of Harbor core. So we do not want to keep the logic in Harbor core. So let's introduce the current design of this feature. Now Harbor using the processor interface to process the artifact types. We now have 4 processors here. We have a Helm chart processor and OCI image processor and the CNAB processor, and we have one default processor for any other artifact types, and we have 2 base processors which will be embedded into these implementations. And if we want to support a model, for example, we have to add a new processor. We call it model processor in Harbor core, and we can use this processor to abstract metadata from the artifact or abstract the additions from the artifact. And we think this approach is not extensible, which means that if we have one more OCI artifact type, we need one internal processor, and we also need one maintainer for the processor. We call the problem monolithic monsters, because if we have more and more more and more artifact types, we have to implement more and more processors here, and the hardware will be monolithic, and it is not easy to maintain. Besides this, we also have some artifact types which is private, and we will not open source it in the future. So if we keep the current design, we may have several folks in the community. For example, if we have some internal artifact types in SciCloud, we will have to fork a harbor and use that fork to serve our internal artifacts. And it is similar to Tencent or NetEase or some other companies. So we will have more and more artifact types in the future, and we do not to make harbor a fragmented platform. So we do not like this approach. And this is the motivation of our proposal. And after that, we will discuss about our design for this for the problems. To address these problems, we have two design choices. The first one is we call it in-tree implementation. So in this approach, we will just implement a new processor. We call it common processor. So this is the workflow to upload a new user-defined artifact to harbor core. First, we will post the blobs to the OCI-based registry. After that, we will ensure that the registry exists, and after that, we will put the manifest to the registry. And you can see we will use our user-defined media type for the config layer, and we will also use the user-defined media type for the layers, for the content layers. And after that, we will ensure that the artifact by digest exists in harbor metadata. And in this process, we will use our common processor to abstract the metadata or the additions. So this approach is similar to the current design, but we will add a new processor. We call it common processor. And to support some kind of extensibility, we will introduce a schema in the user-defined config. And here is an example. And we can have a deeper dive in this graph. So this is a user-defined config, and we call it config layers. So in the config layer, we will store such a JSON object, and you can see we defined some user-defined configs, and besides it, we have a field we call it harbor, and in harbor object we have another object, we call it user-defined artifact, or we can have a similar name, but we just store some user-defined artifact details here. And in this field, we just store the icon of our own type, and we also store the kind of the artifact, and we will store the artifact type and additions here. The most important section is additions in this field. In additions, we will store how many additions should be used in our customized artifacts type. And you can in this example, we have 3 additions here. The first one is readme, and it will be stored in a separate content layer. And we will store the blob reference in the addition slice, and you can see it's here. And the blob points to the content layer, and its digest is recorded here. And after that, we have a table content layer here, and you can get the content. You can get the table content layer from this blob layer. And finally, we will have a general layer here. General layer means that we do not know the format or the context in the layer, but it is not the real content layer. It is an addition. So we call it general addition. For readme, you can see that we have content type, text, and we have formatter. For example, readme is a kind of code, and its format is markdown. So we use this approach to let Harbor know what kind of content, what kind of addition it is. And it is similar to readme. The updates is the update stores a formatter which kind of is table, which means that this content layer stores a table, and we will show it in our UI as a table. So when we have such a schema, we can implement the processor like this. We call it common processor or general processor. In the get artifact type function, we will first pull the config from the artifact, and it is the config layer, and we can get the artifact type from the config layer. We can get the config layer dot harbor dot user defined artifact dot type. Then we can get the get this value ORMB, or we can modify it to model or something else. So we can use this value as the artifact type. And in this function list addition types, we also do the similar logic. We pull the config layer first, and we can use config layer dot harbor dot user defined artifact dot additions dot name. We can use it. We can iterate the additions to get the names for every addition, and we can use the name slices as the return values of this function call. And in abstract metadata, we can use. We also use similar logic. We pull the config layer, and we set the metadata to the config layer JSON object. And after that, we can get the config layer in the Harbor API core. So it is our motivation illustrated in the previous section. Yeah. And the last one is abstract addition. So we will pull the config layer first, and we will get the addition digest from the config layer. And after that, we will pull the addition blob from using the addition digest. And after that, we will use the addition layer as content, and we will parse the type from the condition layer, config layer dot harbor dot user defined artifact dot additions and additions to get the type from the config. For example, if we are trying to get the README addition, we will get the formatter from the config, and we will know that it is a README file, and we can return the type. This type we can set it to README or text or something else, and we can set the content to the blob layer content. And this is a valid addition to Harbor UI, and we can show the README in the UI. And this approach, we call it in-tree approach, in-tree implementation. And besides this, we have another implementation here, and we call it out-of-tree implementation. And in this approach, we propose a new processor. We call it HTTP processor. And the HTTP processor will communicate with the processor extender via RESTful API. And it is similar to the Kubernetes scheduler extender, if you know it. And the logic is a little different from the previous way. We will use the HTTP processor to abstract metadata, and the HTTP processor will post some RESTful APIs to the processor extender to get the metadata. And it is the main difference between these two approaches. And so in this way, we will have some changes to Harbor. We need a new implementation HTTP processor, and we need a configuration YAML file processor.yaml. And in HTTP processor, we will define 4 APIs here. And the first one is to get the artifact type, and the second one is to get the addition types, and the last two is to abstract metadata and abstract addition. So we can have a look at the sample how to implement the abstract metadata. So when the user call HTTP processor.abstract metadata, we actually send a RESTful API to the processor extender. We will have a manifest in the request body, and we will have the artifact in the request body. Besides this, we also need some information about the registry to allow the processor extender to pull the manifest from the Docker registry, from the OCI registry. And we need the URL of the registry, and we also need some token for the registry to pull the manifest eagerly. And besides this, we need to register the processor in hardware core. So we need processors.yaml to register corresponding types. The format of the YAML looks like this. We need to define some processors, and in each processor, we will define the processor URL here. And we need to define the artifact type, media type. When hardware core get some request for this type, we will use this processor to process it, and after that we will register this artifact type to the hardware registry, and after that the hardware can know to use which processor to process the corresponding artifact type. And in this way, we have three things to do. The first one is to implement the HTTP processor, and the second one is to implement Auth in HTTP processor, because we need to let HTTP processor extender to pull manifests from hardware registry directly. And the last one is to registry. It's about registration using processors.yaml. And the development process is like this. We first need to implement the HTTP processor and the extender without Auth. And after that, we need to implement the registration. And the last one is about Auth. And this approach is about the out-of-tree approach. And you can get the details in our proposal. And that's all. We already illustrate our motivation for this feature and our two design choices here. And we are open to the community and welcome any suggestions here, and we can discuss about it.
So I have a couple of questions. Can you go back a few slides to where you had the icon for the manifest, where it showed the icon and
yeah.
The next, yeah, this one, yeah. So yeah. I think it, the way I envision this is that when we look at this from a plugin architecture, is that someone submits the schema for these user-defined artifacts that contains all this data. I would assume the icon will be part of the schema. Think of this as almost like a zip file that contains an icon, and this file that contains the schema, so that Harbor doesn't have to go pull the icon from a URL. I think that's going to introduce performance problems in the UI, and it's not a scalable model. So the icon has to be embedded into the plugin. So think about that. And then my second concern, and this is more for Daniel Zhang, and I don't know if Daniel can chime in here, is when someone introduces a new artifact that's basically OCI compliant and it wraps a collection of other artifacts, Harbor has a lot of set of capabilities around policy, like for example, quotas, retention policies. All of those obviously work for pretty much any OCI compliant artifact, but not everything. For example, scanning doesn't work for just about any artifact. So it'd be great to know in this schema if scanning can be enabled on this set of artifacts, because we need to know how do we enable, static analysis, whether that's by Privy, Claire, or something else on the back engine?
Okay. For your first suggestion, I will have a detailed review with our colleagues to give you a reply. And as far as I know, the icon URL here is not will not be used directly by Harbor core services. It will be used by Harbor UI to pour the icon directly from the browser. So I think we do not need to embed it into the artifact. As you know, the some other standard artifact types like CNAB or Helm chart, they also do not embed the icon into the artifact.
Oh, no.
So,
Yeah, I wasn't suggesting embed the artifact in the icon. I was suggesting we have a plugin model where you upload an artifact type into Harbor, and the artifact type contains what does the structure of the artifact will look like, including its icon. You only upload it once, and then once Harbor sees that artifact, it knows how to recognize it.
Yeah, okay, yeah, sounds good to me, yeah.
Michael, I think there's some misunderstanding here. The idea here is that any user-defined architect will follow this schema in the config.json blob.
Yeah.
Yeah, there's no registration, right? If you use upload, that's mean you need to register, do registration. That's
so essentially we'll allow basically any artifact to wrap anything into an OCI list, and this config schema will include details. I want you to think about what it would mean like to basically, if you have lots of these artifacts, what it will mean for our UI to go load that icon from a URI, right? Whether that's local or otherwise.
Yeah, as for the icon, I think we can have a lot of time to discuss. I think that we have to make decision, or the main decision we need to make in today's discussion is which approach we should choose, whether it's the in-tree configure JSON based processor or out-of-tree processor.
Yeah,
I think that's the decision we need to discuss.
Yeah,
As for this detailed schema, I have a lot of comments. I don't want to go over them one by one.
I just mentioned this is just an example schema, not a schema spec yet. So I agree. We need to determine which approach we should to adopt, in-tree or out-of-tree.
Yeah, so I think we do not need to dive into the details of the schema here because it is just a draft and we do not make a final decision. So we can just, we want the community to give us some input to choose one design choices. For example, we want to use in-tree implementation or out-of-tree implementation. But as for the details of the schema, I think we can have another meeting or something else to decide it,
Yeah, actually, one question I want to ask Cer. Actually, in your background, you mentioned there is some user-defined artifact types that you don't want to be open source. Right?
Sure.
But that if it is if for the in-tree you need to expose your information, metadata information, right? Expose the information in the configure JSON file. That means your.
I mean, either way they need to. I mean, either way they choose in tree or out of tree. The information is in somewhere in this artifact.
But out of tree, but over tree.
I know your concern. I know your concern. As you know, we will, for example, if we want to have an internal artifact type, we will define the specification for this artifact type. And in the specification, we must define the Harbor-related fields. And it indeed will be used in Harbor core, but this Harbor instance is maintained internally. So we do not have any concern about it, I think.
All right. That's correct.
Yeah, the Harbor instance is running internally, and the artifact specification will be exposed to this internal Harbor instance. So I think it works for us. Yeah.
Okay.
And
so I think the two main differences maybe is one need to, we need to define a spec, right? Everyone, if they want to Harbor support to process their data, they need to follow that spec. But for the out of tree, we don't have we don't need to define a spec, right? Everyone can follow the spec, follow the API to introduce the capability into Harbor.
Yeah, you can you see my screen? Actually, we have some pros and cons for these two design choices here. And as for in-tree implementation, it is easy to mention and no extra effort to support new types because we just mentioned one common processor here. And it is also more secure than the other approach because we do not need to let the extender to pour the manifest from the Harbor core. And but we cannot support some ad hoc cases in this approach because, for example, as you know, CNAB is not stored its config in the config layer directly, and we have some ad hoc code in CNAB processor to get its real config layers, and such kind of logic cannot be implemented in this implementation. And as for out of tree, it is it has higher extensibility, but it also causes higher maintenance costs. So, yeah.
I don't think the example you mentioned, the CNAB example, is quite valid here because if they want to show something on Harbor, either way, they need to do some work. If they choose in-tree, they need to write their config.json following the schema. If they choose out of tree, they will write a processor. They will write a service to support that. So either way, there's some work. So we cannot.
But for out of tree, if there are already some user-defined artifacts there, they have a fixed structure already, so they don't right. If in-tree, you cannot let the user to change their already defined metadata structure to follow our new spec.
Right.
But for out of tree, they can provide an extending processor to handle their own structure. So
I mean, out of tree, it appeared to be more extensible, but not exactly. I didn't follow the whole sequence of flow for the out of tree, but essentially Harbor still need to get some blob and let the API to pull some blob. So how does the HTTP processor know the digest of this blob? There is still some contract here, right?
The Harbor, the HTTP processor have to pour the manifest first, and he will put the manifest to the request body to the processor extender, and the HTTP this extender will use the manifest to pour all the config layers or content layers from Docker registry or some other registries. Yeah. So from my point of view, I think currently I prefer the first way because it is easy to implement and easy to maintain. But if we have advanced use cases in the future, we can have a look at the out of tree implementation. But as for now, I think currently we do not need such a advanced feature to support the use cases because our model specification is easy, and we do not need such a big thing to implement. Yeah.
And I think the entry also can be reused by other artifact authors, right? So if we set the standard for what the config should look like, then we can push this out to every vendor that wants to be hosted on hardware. Seems like the effort is lower, right? It's less friction to get something to be able to push to hardware, because just writing something in accordance to a config spec is much easier than writing the actual HTTP processor and whatnot. Right?
Yeah.
I didn't really understand.
Yeah, but I'm still afraid of that for the in-tree approach, because there is a spec, there is specification. That means the user-defined artifact type is built on top of this specification, not built on. Of course, they must be built on the OCS spec, but they need to follow both OCS specification as well as our new harbor user-defined artifact specification.
I think there is some misunderstanding
but for
here.
auto tray, they don't need to follow any spec.
Yeah.
I think they still need to.
I think,
I mean,
to me, I think the Auth tree, the most benefit of Auth tree is that the user can control their privacy of their artifact.
No, they can't.
They can't.
But except that most of the logic should be similar, right? It's just like a content process logic, right? Either you do it inside or outside, it's the same. It doesn't seem too much difference.
Yeah, I just want to point out the Auth tree doesn't protect any privacy, because everything is in the artifact and everything has to be uploaded to hardware.
Yeah.
Well, in entry approach, whatever you don't want revealed, you can just leave out the config, right? Just put in whatever you want. So
could you repeat?
I think, personally, I think privacy is not important.
Yeah, I just lost my connection, but I want to hear my question.
We lost you again.
Yeah, we lost you. We can't hear you, Stephen.
Yeah, I think I understand his point. His point is I create an artifact and I can update my external processor if I want to change what information I want to pass to hardware.
Yes, because for the entryway, we have we have a harbor specification. That means the user-defined artifact should be follow the both OCS specification and our harbor user-defined artifact specification. Then their information can be rendered by harbor, right?
I don't think this is very reasonable, because even for the out-of-tree processor, they need to get some data that is readable by harbor, right? They cannot do whatever they want. They still need something that harbor understands.
They don't need to stay on the specification. They just to provide some formatter information like JSON or some array list.
I don't totally agree, because there is still a spec in terms of the response data structure.
There is another disadvantage if some user-defined artifact has been defined before our specification is published, they cannot still be rendered, because if they want to they need to change their structure to follow this new spec.
That's true.
But for auto trade, they don't need it. They can provide a new.
They don't need, but they need to develop another.
Yeah, they still need some development work.
JSON file and the relative processor class, right? That they need to do.
No, they don't. They just need to provide extending logic, right? Extending.
Yeah. I mean, that logic should be written by the
harbor.
Right. That's true, but right. I don't think that's
so. Both way have obvious disadvantage and advantage.
I think biggest concern for Olive Tree is how do we manage these external services and how do we make sure it's secure? Because we are.
Tra had mentioned we don't need to provide some registration management API like a scanner. Do you know? It's just in configuration, configure through hardware, some configure file when this install when they install in hardware.
I'm not sure this is correct because then the hardware's life cycle will be tied to this HTTP processor. For example, if the host name of the HTTP processor change, we need to restart hardware.
Yeah, but that's reduce the effort to.
Yeah, and for example, the HTTP processor is serving HTTP as how do we establish the trust between these two? I think there's a lot of.
But you change the schema or you change the DNS. I think it's a normal case you need to restart hardware because currently if you change some configuration of hardware, you also need to restart. That's acceptable. That's reasonable, right?
I don't know. I think
the configuration.
I think there are more.
Given the
I like failover case, we need to consider this HTTP processor can be down. It can be, the certificate may be rotated, and even this processor may be compromised by malicious user. So I personally strongly prefer entry.
Your hardware component system may be also compromised.
I think the Autumn tree implementation will not affect hardware current workflow because even if the processor is broken or it is down, the hardware just cannot read the user-defined artifact types, but the existing functionalities can work. So I think it will not affect the.
But the processor may, but the processor may return something malicious to hardware after it's compromised.
It's
and
just,
hardware need to.
No, I don't think so because the return is predefined model. We have predefined model. If your data is changed, I don't think we can accept the data.
Also, the robot account may be leaked if it's compromised, and they can use the robot account to pull other artifacts.
What's okay? That's a similar security risk to other, other internal service like other scanner or other something.
But that's different from scanner because take Aqua for example. Aqua has to support configure a registry. So they already have a very secure way to store the username and password, but we don't have that for HTTP processor. The HTTP processor will need to develop a very secure way to make sure this information is not leaked. But Aqua, we can trust Aqua because Aqua already have that technology.
So how about?
I disagree because between Aqua, because the backend scanner, there is an adapter between hardware and the backend scanner. Right. That's also a weak point.
Yeah, but we have no choice.
If it's compromised.
But we have no choice because
I think the rule of this HTTP processor is very similar to a scanner adapter, not a scanner itself.
But that creates additional attack surface.
Right? Have we certified Aqua, Daniel?
We don't certify Aqua, but Aqua has technology to scan image in other registry. For that, Aqua can manage the credential for the other registry securely.
I think we need to treat this deployment as a whole deployment, not as a separate, right? Because for the user case, they provide the HTTP process as the new, as the new component service to their platform. However, together with this new processor as a whole, artifact platform, not the hardware itself. So they should protect that.
I think not.
Reasonable security.
No. I mean, if you treat HTTP,
why not you put it in tree, right?
Yeah. If you treat it as a whole, you lose all benefits of out of tree.
Yeah.
No. Out of tree, because you have separate process. It's very easy to change to to extend.
But it's a whole, right?
Difference. Not in tree, out of tree. What?
No, not quite.
Because in tree is maybe the logic is something similar, but in tree you need to build together. You cannot easy to do change, right? To do extensible, to change some logic. And it's very hard to extend, right? But for out of tree, it's easy. That's the advantage of the out of tree. Out of tree will not influence hardware base, right?
But you mentioned you wanna.
It will serve as an extra external service, right? So.
But did you say you wanna use this HTTP processor with hardware as a whole? If it's a whole, it's not out of tree. If it's a whole, they can't have separate life cycle.
But for one user, if they determined to use it, they can bund the hardware and their extender together. But switch to another user's context, they can easily to use their own extender together with hardware. So, but for two different users, that's the extensibility, not for one user.
Yeah, so I think just to sum up, there are good arguments on both sides. It seems like the entry is safer, lower barrier to entry, and it's extensible to other artifact authors. That's my take on it, but we can keep discussing on the proposal itself. I fail to see where out of tree is better, other than it's more extensible. But the work that TiCloud does to onboard their artifacts, that can be replicated by someone else, right? Whereas if we dictate what the spec looks like for the config, yeah, you can't change that easily because it's in tree. But it's like any other piece of software, right? You have to take the effort to design it, and then once you design it, just stick with it. So I think tree feels like it's easier. It feels like it's more extensible to other artifacts that want to use it.
But don't forget the entry approach. You need to define a specification. Schema.
Either way, we need a specification to make sure the processor returns something that hardware understands.
Yes, I think that's also my understanding.
But for out of tree, it's just data mode. But for that, it's more complex.
So, how many artifacts are we going to support? So initially.
From my point, in this year, we will only support one artifact type, and maybe in the next year we will support another 2 artifact types, and maybe one of these artifact types is private. Yeah.
And I also had a question: what kind of or what is the volume of data we're looking at? How many artifacts? How much storage? What kind of storage do you usually use with it? Is it file storage? Is it object storage? Do you have some numbers on that?
We do not have the numbers for it yet.
Okay.
So I have a question. Do you require Harbor's UI, or do you have your own UI?
Now we want to have our own UI because Harbor's ability is just one part of our model registry, and we also want, we also want to have some other functionalities like model conversion or model compression or something else, and we do not want to.
So I still have some comment regarding in-tree, because we may want to separate the data and the UI. We don't want to, put the metadata-driven UI in config.json. But we can discuss that later after we make decision in terms of in-tree versus out-of-tree.
So I have one thing I want to claim is that we call it out-of-tree is not because we will not put it in Hover. We just want to show that the extender logic can be separated with Hover core, and we can maintain the extender code outside of Hover. And but
But if you put out of tree inside Hover, that's more problematic because we need to handle it in installation. so again, I prefer in tree, at least for this case, or for now. Yeah, I understand the out of tree is more has better extensibility, but we don't have a lot of artifacts we need to support now. Maybe one day we should move to out of tree, but let's hold on for a little bit.
No. I still disagree. We don't should count on the numbers. That's not should be a temporary solution. We need to determine which one is better, not just say current only one. Maybe because the framework is it's extensibility, not just one step thing.
Yeah. So for example, if we choose in-tree, we spend 1 month to discuss. If we choose out-of-tree, I expect we will spend much more time. Because I see
yeah, please.
So we're almost out of time. I don't want to go over, but I think good discussion. We know it's kind of the options we're looking at. I think this is the first step before we look at details around what the actual stack looks like, the in-tree versus out-tree. I think so. I will share this PPT on the community meeting notes as well as the community PR. Everyone can head over there and ask some comments, ask questions. We'll probably have another meeting, outside of this community meeting to discuss this. And if anyone's interested, please ping me. I can invite you as well. We'll have the community PR. There's going to be a PRD on it that I'll share on the GitHub ticket. So definitely more to be discussed.
Yeah. Okay. Thanks for your time.
Thank you. Thank you for your proposal.
Thanks for sharing.
Bye.
Thank you.
Great idea, I think.
So I'm stopping the share screen.
All right. I think if nobody has any other questions, we can end here. We're right on time.
Bye-bye.
All right. Thanks, guys. Thanks for attending. Bye-bye.
Thank you. Bye.
Thanks.